So what I discussed in the last lecture was about hydropower plant. So we discussed about the construction of the hydropower plant, everything, and previously I discussed about the hydropower plant coming as a part of conventional source of energy. Even it can be considered as a non-conventional source of energy. So that was just a personal opinion or personal point which I put. But you will find it in some sources as a conventional, or you can find it as a non-conventional in some sources. So it's a point to debate. So again, there's a conversion of hydraulic energy, which is from the potential energy which is stored, which is in the water. So water stored at a height will have the potential energy. So that energy was converted to the kinetic energy using a penstoke. It was converted to pressure, and again that was converted to kinetic energy from the nozzle of the penstoke, or using the nozzle the pressure was converted to kinetic energy. Again, it is possible that the flowing water will have the kinetic energy and water will be at some pressure, and again you are converting that hydraulic energy or whatever energy stored in the water to mechanical energy while it is acting upon the turbine. So the turbine needs to have a specific kind of construction, and depending on the amount of height of the dam, there are different kinds of turbines. So I will discuss in detail and the classification and everything. And again, what was happening is that the pressure, the mechanical energy was being converted to the electrical energy using the electrical generator. So again, there's the power produced by the hydropower plant is given by the equation WQH and H into the efficiency, and this power is in watts. So this is a power which is produced. So W is the specific weight of water in Newton meter cube, and Q is the rate of flow of water in meter cube per second, and H is a head per fall height. That is, H is the height of the dam. So the more the height of the dam, the more the potential energy. The less the height of the dam, the less the potential energy. The more the height of the dam, the more the kinetic energy possible, because the water will be flowing from a higher height. Also, the length of the penstoke can be longer if the height is larger. So different kind of construction is possible. Again, the efficiency of the hydropower plant is usually high in the range of 90 to above. So again, there is a high head plants which is from 100 meter and above. Then there is a medium head plant which is from 230 to 500 meter. So, and there's a low head plant which is up to 50 meter. So the low head plant, so all these are the construction of the dam. So the dam is how much meter high, you can classify it as high, low and medium. So again, the device or the equipment, the mechanical equipment which will convert the hydraulic energy to the mechanical energy, or the potential energy stored in water to the mechanical work, is known as a turbine. And the different kinds of turbine is Pelton wheel, Kaplan, or it can be Francis. So the Kaplan is usually a propeller type turbine, and these kind of turbines are found in the rotating motors or the propellers of ships and etc. So if you could imagine that, or if you would have seen that. So again, these are the Pelton is a impulse turbine, and the Kaplan and the Francis are the reaction kind of turbine. So as you can see in the diagram of the Pelton wheel, so there will be buckets on a round wheel, and the water from the nozzle will be flowing at a high velocity on these buckets. So whenever it will strike the bucket, so the bucket could be like that, and the water could be striking it, and this will cause a rotation. So again, there could be multiple nozzle, or there could be a single nozzle kind of construction possible. So all these are details in the mechanical. So if I'm covering that, or it would be difficult to cover that as part of the series. But again, there could be single nozzle, there could be multiple nozzle, and the water which is leaving, it will leave to the outflow or tail race. Again, there could be a draft tube provided, so in such a way as to increase the pressure of the water which is leaving the towards the tail race, to provide a smooth outflow. And the reason is that as the water energy has been converted from the pressure or the potential to the kinetic energy, the water leaving the turbine blades would be at low pressure, and you need to provide a medium for it to live easily. So raft tube kind of construction will provide an easy way for the water to exit. So again, these kind of turbines are the tangential flow. As you can see, the water is hitting the turbine blades in a direct tangent to tangential way. So these kind of turbines are known as the tangential way, and they are also horizontal axis turbines. So the horizontal axis, the axis of the turbine will be horizontal. So it will be horizontally constructed, and the turbine wheel will be located horizontally, and it will cause a rotation, and the connected shaft will be connected in a horizontal way, or the generator will be coupled in a horizontal way to the turbine. So again, it is possible mechanically multiple ways to connect it, but the shaft of the turbine will be in a horizontal construction. So the next kind of a turbine is a Kaplan turbine, which is used for low head up to 80 meters, and then there's a Francis turbine. This could be used from 80 to 100, 500, etc. And these are the impulse and reaction turbine. So when the velocity of the water is large, it is possible to use Pelton wheel turbine, and if you can say that there's a large quantity of water but the velocity is less, in such kind of arrangement where the head is lower, like 80 meter head or 80 to 100 meter head, in such cases it is Francis turbine are used, since the water will be available in large quantity, or the water which is made to flow over the turbine is in large quantity, as it is not possible to generate the water at the amount of pressure and velocity needed, since the head is low and the water will be flowing at a low velocity or a low kinetic energy, and it will not be possible to generate the amount of kinetic energy or the velocity of the water needed to have a large amount of power production or large amount of energy conversion in the way needed. So in such cases there would be the reaction turbine. So again, the classification, the impulse turbine is a Pelton wheel. It is a high head and low rate of flow. That is, a kinetic energy will be high, but the rate or the amount of water which will be flowing will be less. Then there will be reaction turbine. The low head will be low, the quantity of the water will be large, and there will be high rate of flow. So again, the tangential flow is Pelton wheel, the radial flow is Francis turbine, the axial flow is a Kaplan turbine. Again, if you look at the shaft, if you are having a horizontal shaft, then it's a Pelton wheel, and both the Francis and the Kaplan turbine are horizontal shafts, so that they will be in a horizontal way, and the shaft will be up, and the water will be made to flow into the blades. It will be made to flow into the blades in a way that there is a reaction causing, and it will cause it to rotate. So that's one way. So as you can see the diagram of the Kaplan turbine, it will cause the water will be flowing from the top, and this will cause the shaft to rotate, and when the shaft will rotate, it will cause the turbine to rotate, and the turbine will rotate, it will produce the electricity as always. So that was just a basic one more lecture about the different kinds of turbine for hydroelectric power. So there, what you saw was Pelton wheel, then you saw was the Kaplan, and when you saw was the Francis turbine. So now we have produced the electricity, we have the substations, we will transfer the electricity, and etc. will happen. So the next lecture I will cover about will be about the wind power, then I will cover about the hydroelectric power, also I will cover about the gas-based power plants, and finally what I will be covering will be about that's all. So again, the description you will find the full playlist of the different videos in this series, and also the other videos related to the electrical engineering. If you like this video, please do subscribe, like and comment. Also, if you have any topics which you want to discuss in this series or related to electrical engineering, or any other videos related, topics related which you want to make a video of, then I will make that if you can comment that. Also, do subscribe, do comment, do like,